because if you wrote everything big, you end up with something like that, and you just don't know what's going on. So make sure you vary the sizes of your fractions. Okay. 5/3. So we've worked with pi thirds, which is, I'm sorry, I want to summarize a little bit here. So can I erase this here? So our first special angle is 45 degrees, which is pi fourths. Then we worked with 30 degrees, and 30 degrees we decided was pi sixths. And then, looking at the same triangle, I went out to that other angle, 60 degrees, and that 60 degrees is pi thirds. Okay? So those are the special angles. And all other special angles come from those special angles. Except let me add on a few more special angles, right? Certainly there's 0 degrees. That's the same as 0 radians. There's 90 degrees. 90 degrees is the same thing as what radians? Pi over 2. You know, there's 180 degrees. That's the same thing as pi. There's 360 degrees. That's the same thing as 2 pi. Right? So I'm always using these angles to help me cope with everything else. But these are the building blocks of all the special angles. And what have we done? We've gone through and we've taken cosine and sine and tangent and just kind of figured it out one by one by one by one. What I'd like to do is I'd like to kind of bring it together. And I want to show you another thing that I've committed myself to memorize. Just like secant cosine, secant cosine, secant cosine. Right? The secant is 1 over cosine. And then that's how I figure out cosecant. So cosecant must be 1 over sine. Right? Secant cosine, one of the things I've memorized. Here's another thing that I've memorized. And that is this table for cosine. And this table for cosine I've actually put in the first quadrant. So I have my special angles, and that's 60 degrees. No, that's, thank you, 30 degrees, which is pi sixths. And then you have 45 degrees, which is pi fourths. And then you have 60 degrees, which is pi thirds. And then you have 90 degrees, which is pi halves. And then you have 0 degrees, which is 0 radians. And so what I have, if when I took exams in this, and when I teach this, one of the things I'll do is I'll write down this table. I need to fill in the cosine values, but that helps kind of ground me and helps me work off of everything else. So the first thing I want to do is I want to talk about the cosine of 0 degrees. This, it's fairly hard to draw because what am I supposed to do? I'm supposed to draw a right triangle, and I want that angle to be 0. Well, as soon as I make that angle be 0, it's not a triangle anymore. Okay? So I'm going to draw a triangle in which I'm trying to make that angle as small as possible. Right? So this is going to be a really small angle. And I want to look at the legs, and I want to look at that hypotenuse. And so what if this hypotenuse is like the number 1? You know, these legs here, I'm not even going to figure them out. I'm just going to try to kind of think about them. So this hypotenuse is the number 1. If this angle is incredibly small, i.e. if it's really close to 0 degrees, what do you know about that height there? If that angle, if that angle is really small, what do you know about that vertical height? Just language, you know, small. So if this angle is incredibly small, and you make it even smaller, and even smaller, and even smaller, that height there is getting smaller and smaller and smaller and smaller. And then, if you make that angle 0 degrees, what are you making that height into? 0. So what I allow myself to do, and this is just a metaphor, I allow myself to write 0. That has length 0. It doesn't have length, yeah. When that's 0 degrees, that height is like a 0. What about this side here? So this side here, when that angle gets smaller and smaller and smaller, you know, what does this side look more and more like? It stays the same. It stays the same. Okay, you're totally right. When this angle goes to 0, tell me about the length of the hypotenuse compared to the length of that side. It's the same, she said. Okay. So when that angle goes to 0, that angle goes to 0, you know, then that hypotenuse is that length, and then that hypotenuse is that length, and that hypotenuse is that length. The length of the hypotenuse is exactly the same thing as the length of this side. So again, this is a metaphor. This isn't true, the picture I'm drawing. I think, all right, the length of that side is like a 1. And I even think to myself, you know, this satisfies the Pythagorean theorem. If I take this leg squared plus this leg squared, I get the hypotenuse squared. I get 1 equal 1, which is true. So again, it's impossible to draw a triangle that has angle 0. But if I think of it being incredibly close to 0, then I think, this is about 1, that's about 0. So now, what's the cosine of 0 degrees? 1, she says. How do you get the cosine of 0 degrees? Basic over hypotenuse. What about the sine of 0 degrees? 0. You take opposite over hypotenuse. Opposite over hypotenuse, you get 0. So the cosine of 0, the sine of 0 degrees is 1, 0. So then I want to notice this pattern. Look at this. I'm going to write up the values of cosine. I'm going to write up the values of cosine. What's the cosine of 0 degrees? The cosine of 0 degrees is 1. What was the cosine of 30 degrees? I'm reading your mind. Correct. It was root 3 over 2. What was the cosine of 45 degrees? Root 2 over root 2. What was the cosine of 60 degrees? 1/2. And then cosine of 90 degrees, we haven't done. Yep. So when I look at this table of values, I think, all right, here are just these wacky different values. How the heck am I ever going to memorize all of these wacky different values? And this is how I've figured it out. 1 is the same thing as the square root of 4 over 2. 1 is the same thing as the square root of 4 over 2. And then what's the next value for cosine? Square root of 3 over 2. And then what's the next value for cosine? Square root of 2 over 2. And then what's the next value of cosine? Square root of 1 over 2. And then what do you think? What do you think is going to be the next value of cosine? 0. It's going to be the square root of 0 over 2, which is the same thing as 0. So this, I know this picture. Right? So what have I committed myself to knowing? I know that the cosine of 0 is 1. Right? That is burned into my brain. And then I think to myself, oh, that's square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2. That gives me all of these cosine values for these special angles. And then this you shouldn't write because it's just going to mess it all up. What's the sine of 0? What's the sine of 0? 0. All right, so don't write this. Okay. So sine, cosine starts big at 1 and gets smaller, goes down to 0. Sine starts small, and then you've got 0. What's the next value of sine going to be? 1/2. Next value of sine, like it doesn't practice. So square root of 2, square root of 3 over 2, square root of 4 over 2. So sine starts big and decreases. I'm sorry, cosine starts big, decreases, sine starts small, increases. So so I memorized this, and if cosine of 0 was 1, then sine of 0 must be 0. And so then I know that cosine must increase and sine must decrease.
I'm sorry about stretching like that. I'm sorry.
This cosine is negative 2, which is what I helps me understand how, because in the other examples I saw, there's other coastlines.
Like all
And the
the
other
angles.
quadrants, they were saying they get negative,
Yeah,
and
that's
down
right.
here.
And so
you see
next class, I'm gonna talk
The,
about all of
the
these.
sign, I feel